Welcome to our first live stream on this channel. Good evening, good afternoon, and good morning, wherever you are in the world. I see a few of you in the live stream. We can see the chat. It's my first time doing this. I'm using StreamYard. Now, today's topic, Tesla Investor Day. Tesla Investor Day may have disappointed some institutional investors who were looking for probably a more detailed gigafactory expansion plan, let's say like a roadmap or calendar over the next 2 years. The institutional investors may be looking at demand projections quarter by quarter. Is demand still healthy? They need to make sure that their models are aligned. Institutional investors may be looking for more details on the third generation cars, the specs, the pricing, the launch date, the launch markets. And institutional investors are probably looking for stock buybacks. None of that was really talked about in Investor Day. On Twitter, some retail investors also expressed their disappointment. Today, I've invited Kelvin Liu, a Tesla investor and also an engineer from Nokia and Continental. He's been on our channel a few times to just join us on our first live stream. Our goal today is to get an engineer's and also a long-term investor's view on Tesla Investor Day to see what did we miss, to get Kelvin's help to help us find the signal amongst all the noise. Kelvin, welcome back to the channel.
Hello, everyone. Good evening. I hope you can hear me fine. So I hope we have a very informative evening. So feel free to jump in, ask questions. If I have any mistakes, if you think that you don't agree or you agree or you have any critics, just feel free to type in the chat. And then I'm sure one of us or our producer will, highlight it, and then we will address it as the program goes on.
I'm already seeing so much love in the chat. Bunti is saying going to the moon together. Franco James saying time to buy the dip. We'll find out in 28 minutes how far the dip goes. Things like minus 5% pre-market, right? And seeing a lot of love here, Chris, Zankit. Thank you for the support. So click subscribe to stay updated to more videos and now live streams on Tesla. Kelvin, love to hear from you. What were your key takeaways from Tesla Investor Day?
Well, okay, so let's probably wait. Let me put it to the first slide. So let's preface this whole Investor Day presentation today. So those who maybe do not know me, firstly, I'm not a trained financial advisor or someone who is very good with numbers, but I'm a trained engineer. And what I got from the Investor Day presentation mostly was on the how are they going to scale their production. So there are a few takeaways or a few insights that impressed me, and I hope that I can share and let the masses know that actually not everything is hoping for a new product. Not everything is just a shiny new object, because a lot of us are trained, or a lot of the, let's say, consumers or the market, they are trained to expect new things, and they do not see how difficult it is to bring that product to the market. So there are a lot of things under the surface that are being done, which actually improves the whole business case of that product, which improves the appeal of that product, and also it improves that supply. So if you have a very appealing product but you don't have a supply, then it will be an issue. Or if you have a lot of supply but you don't have that appealing product, it's also an issue. So I saw the balance and the sort of the vision from this Investor Day. So I hope I can share this and see if get more feedback from what people think, and also to educate maybe some less engineering people, right, to appreciate how complicated a production process is, or how complicated or how much effort that a company needs to put in to actually bring a product to the market, and a product that actually can appeal to the whole world, and also to sell and to create value to the society. And all this is also important because as an investor, right, you cannot just see what is a new product, right? You have to see the profit margin. So I also can appreciate the fact that this is a step that can preserve that profit margin for the company and also to keep the price as competitive as possible.
Thank
Yeah.
you, Kelvin. So our friends in our live stream are saying pre-markets down 8%. Some people are saying, what are we missing? I mean, as long-term
Yeah.
investors, what are we happy about? Tell us.
Okay, so let me start by also saying that the investor day was very long, right? And there are a lot of things that they touched upon. So the first part, they talked about a bit about the master plan. So I will not touch about that. I will focus mainly on the just a few moments in the whole presentation, which I feel that is relevant for me to add some input, because the rest like FSD and maybe charging network or whatever, those are not my forte, right? Not in my field, so I don't think I can add any value. So I will start off with what I think the first thing that is very, very impressive, and it's a total paradigm change. It is way more significant than what people think. Okay. Yeah. So I saw one of the chat, it says, why does it mean that they are not doing full body casting? So to be frank, right, it's not possible to do full body casting. Okay, because of the features in a car. If you know that if you want to cast the whole body, right, it's not possible to cast it because you cannot retrieve that part out of it anymore. So I'm not sure how the pattern shows, right? Maybe it's not just two molds like that, so it may be like from up down, but it will be very complicated. Okay, so to me, I don't think that it will come that one full body. But that being said, right, they will definitely increase that casting to be a larger casting to include more parts in it. Okay, so that does not discount the fact that casting will be insignificant. It will be a part of manufacturing moving forward, and also the competitors will go through that method if they see the volumes. Okay, so we need to also qualify casting. You need to have volume, otherwise it doesn't make sense. Okay, because of the cost. So okay, so what did I see to be so revolutionary? So it is the way they assemble the car. Okay, from the starting to the back. So from the first assembly line in the 1930s, I think, when Ford started the assembly line, right? It's considered very revolutionary at the time, because every station you do a certain piece of work, and then in the end it comes together, and you try to reduce as many variants as possible. That means it must be as uniform as possible. That means every car must be the same. Okay, so that was the first iteration of the assembly line. Like, I think the famous quote was that you can get any color as long as it's black. Okay, so that means it must be the same. But as years move on, right, manufacturing became more like you have new methods, like just in time, just in sequence. So the variants come in. So like BMW and some other more prestigious brands, right? They started to create more variants. Okay, so the assembly line can move as well, but every car will be different. Okay, so there will be a blue one, there will be a left-hand drive, and you can actually very, very nicely synchronize everything. Okay, but then comes a problem. The method of assembly has not really changed much, because especially when in the video they also say that you put the car together. Why did they put the car together first? Because it needs to fit first, because there are tolerance issues. So once you are stamping, it's a very dynamic process. Your casting is also very dynamic. You have to make sure that the car comes together first, and then you will put into the paint. Why does it go and one whole piece in the paint? Because of color matching. So different batches will have different colors. Although you use the same mix, it's always like that one. Sure got variance one. And it's very obvious if you have a different batch. So they do that. Okay, that's the traditional way. And then they remove the hood, they remove the doors. Why? Because you need people to go in to assemble the chairs, the lining, the trims, the instrument panel, put in the engine and everything. Okay, so there's still a very manual process, but of course, as time moves on, right, you tend to have a lot of tools to help you, right? You have robots to help you carry the instrument panel and the doors and everything, but still, to like, for example, you put on the wires, right? People have to still climb in. You have to climb in, and then it's not ergonomic at all, because you have to climb in, you have to twist your body. It's very tiring work because there's no place to hold, right? And then it's also very dangerous work. A lot of people get hurt because there are sharp bolts or sharp corners inside the car. You can imagine it's metal, bare metal, right? So it's dangerous. Okay. So now what did Tesla change? They think that they could do things more parallel, okay, not in a straight series way. So that's what the right hand side of this slide shows. They call the unbox process, right? So I would actually call this the modular process. Okay, why do I call this modular process? It is because this platform actually opens up to more variants of car. So you can actually have the different parts, right? Different areas. You can actually have like an SUV. You can have a sedan. You can fix like maybe a two-door car or something, but using the same cells, because here you see like there's 1, 2, 3, 4, 5, 6, almost 6 cells, right? 6 different stations, sort of the 6 different stations. So you can have like the front and the rear would be used across like 3 or 4 different kinds of cars, because those are the front and the back is almost the same. Okay, it depends, right? We don't know yet. So that opens that possibility, lah. So you do not need to close down the whole line just to change a different variant or something like that. Okay, so that's the whole paradigm change. But there are of course disadvantages for this as well, like what I just said just now, color matching. Because if you are going to do things in parallel, you're going to paint the left side, you're going to paint the right side. Suddenly you will see left side is brighter than the right side. So that is the problem. Okay, so that is a challenge that Tesla has to solve, which so far legacy automaker or normal automakers try to avoid, since they know that it makes no sense to control this process. Why don't we just paint everything? Okay, but hopefully they can control it. Maybe they use, I don't know, software or some intelligence, right, to control the process. I'm sure they have thought about it. In other this
unbox process, the way it's done, has any other car manufacturer done this before?
It has been done in small scale, like Caterham. If you can search that brand, right, it's like a kit car. So actually you buy the car and it comes to you in the box, and that's why they call the unbox process. So you open it up and you actually build yourself in the garage. So it's almost this process, and that's where Tesla actually gets the inspiration from. And the Caterham brand, right, they do this, and then you can have like different engines, different colors, something like that. One of the brands, if I'm not mistaken, Caterham. So they call kit cars, and there's more brands around, but it has not really been used or done in the normal mass produced products like other brands. So I think they get the inspiration from there. So they feel that it's also more safer for the employees, because you can see that each part is a small sub-assembly, so you can work in a more comfortable way. You can stand, right? very simple, and then maybe 2 or 3 people can do the work together. The other advantage is, there's one disadvantage also, is that to interface all this together, you need to make sure that the connectors and the wiring, everything can come together. So that is also something that Tesla has to rethink a bit. Okay, so how they're going to add the sub-assembly, and then only later they connect it together. So for example, like strength of the chassis. So if you have different parts coming together, then there's a weak point at the interface. So then they have to think and see how they can improve that process, right? So I don't know. We see how it interfaces with each part, but I'm sure it can be done, because it is actually now being done. It's just that you build first and then put together, instead of you build together and then you put things inside, right? So it's almost the same. It's just a different step.
I'm curious, Kelvin,
So yeah,
this unbox process, Tesla said in Investor Day is for their next generation of cars. Can they do this with the current cars, Model 3, Model Y, or it requires a whole rethinking of how the car is built?
I think what they will do is that the Gen 3 platform will also encompass the new Model 3, Model Y. That means
Okay.
there will be a refresh coming first, maybe 2024 or something like that. I think there are already rumors with Highland and Juniper, right? That will still be the old process. That means it will still be what mostly they are doing currently, but of course with improvements, right? So we don't know what improvements yet, but minor improvements. So it will be more like a mid-life cycle refresh. Okay. Why do they do this? Because they need to keep it a bit fresh so that it can last for another 4 years while they do the next platform. That means either a cheaper model, or maybe, I don't know, maybe they go to van, or maybe they go to two-door cars. We don't know yet. Okay, but I would say they will be the Gen 3, this unbox process will go to the new platform, a new product, totally new product line, but will not be in the Model 3 and Model Y first. But after this is stable, and in the meantime, the next Model 3 and Model Y, because people still need to buy cars, it will be using this process. So probably you will be seeing it at 2028, probably.
So it'll take some time. Can I ask, Kelvin, if let's
Yes.
say Tesla managed to do this well with their new Gigafactory in Mexico and they see good cost savings, so BYD says, damn, that's good. Can they just copy and paste into a new BYD factory?
Actually, I would say yes. Yes, but of course it's not as simple as Control C, Control V, right? So you have to actually streamline your whole process. You have to rethink your supply chain. You have to rethink how are you going to interface all your different parts together, because later we will see that a lot of Tesla controllers, the ECUs, everything is done by Tesla, but legacy, they don't do that. So will they take the effort to change so much? We will see, but it's not something that cannot be done. Actually, a lot of things that Tesla is doing now is not something that cannot be done. It's just that they feel that not worth the effort, or they will feel that casting doesn't make sense. I don't want to do it. Let them do it. Things like that. Is actually is the thing is that a lot of us see let's say hardware or methods, right? It's all can be copied on, but whether you can execute it or not, whether there's a business case, whether your CEO believes it or not, that's a different story.
Yeah. When you talk about execution, I think even in the chat, like Simon is saying the same thing. You can copy, but how well do we execute? And even if, let's say, a BYD copies everything exactly, and they do it well exactly, by then Tesla may have some Tesla bots in the production line already reducing labor costs, making this simpler. So as we've always had this notion that China labor costs are low. Right now, China labor costs are higher than Malaysia labor costs. So Kelvin's in Malaysia, where we just announced news yesterday that Tesla is officially launching.
Yeah,
Kelvin's going to get
finally.
his Model Y, but then it will not
Yes.
be the unbox process yet.
Yeah, no, no, definitely not. And yeah, talking about Malaysia, right? This process actually supports global expansion even faster because of the CKD process. So if those who are in the automotive industry, you know there's the CBU and the CKD process. So CBU means you import fully, right? I think
Can you
Singapore also
explain the
uses the
acronyms
same
for us?
term.
I'll type it out.
Yeah, a CBU is completely built up,
Okay.
and the CKD is completely knocked down.
Lee knocked down.
Yeah,
Oh, my
completely
wife is
knocked
in the
down
live
CKD.
stream. Hello, Grace.
Hi, Grace.
Thank you for
So
the support.
this actually helps the global expansion tremendously. So what the current process is, some countries like Malaysia, right? They have a very restrictive tax on CBU cars because it's fully imported, so it doesn't add value into our economy. So they tend to put very punitive taxes and tariffs on CBU cars. But
Kelvin, can
CKD
I
has
hold you for a while?
incentives. Yeah.
To a 5-year-old, I'm still not clear on what's the difference between a CBU and CKD car. Can you
Okay, right.
tell us
So
more?
CBU is completely built out. That means if you want to buy, let's say a Tesla now, right, in Malaysia, you have to buy from a China factory, for example, right? You
Yes,
don't know where it comes from. Okay, so it comes on the ship with the wheels attached. So that's why they call it CBU. That means you can drive off the ship.
got it.
Okay, you drive off the ship. While a completely knockdown process is that CKD is it comes in boxes. It comes in parts. So it comes to the Malaysian factory. So it forces the manufacturer to actually build an assembly line in the country to get tax incentives. So there are companies that do this in Malaysia, like Mercedes for some of their models, BMW, I think so. Probably, yeah, very likely, very likely. Honda, things, brands like this that can sell at a certain volume. So they will build an assembly plant or they will partner with a local assembler and they ship it in boxes and they screw it together in Malaysia. But of course, there are also other restrictions, like for example, you need to have local employment, you need to have a certain percentage of local parts, things like this. Yeah, Grace said like IKEA,
Yeah,
very good analogy. It's the same thing, but of course, you can screw up in the IKEA process, but you cannot screw up in the CKD process because you're not going to do it yourself. But the Malaysian assembler will be doing it. So then you get incentives. So the funny thing is that if you're using the old way of the process, right? When the manufacturer actually ships the part to another country, they actually build it first. They build it first, and then they disassemble it. They put it in boxes and they send to the country and assemble again. So
same.
that is because to get the tax incentive because it's worthwhile, right? Economically, it makes sense. So it's redundant work. But this process actually helps the global expansion because they are not going to do redundant work. I'm going to assemble some of the sub-assemblies. I'm going to leave out maybe, let's say, I don't know, airbags. I'm going to leave out some air conditioning or infotainment system. I'm going to let the local assembler source locally. So they're going to leave out a few things. They pack it into the box, send it to Malaysia, and then the Malaysian assembler or Malaysian Tesla will then, source the infotainment system from Malaysia, the chips, the brakes, maybe, tires, and then they assemble in Malaysia. So it actually hastens the process. So it will, reduce the redundant work, which doesn't make sense. Did you know that actually engineers in Mercedes, right? They actually have an engineer to think of the way to pack the parts into the boxes, right? So you're actually trying to cram a car, you assemble already, but you disassemble again, you cram it into the box so that you can send to another country to assemble again. So it's work lah, it's work and money, but because now it makes sense, so people do it. But in the future, if you can save this step, then of course you're going to get more of the value back, right? So that's why I think will also help their global expansion tremendously, especially like in
Yeah,
Malaysia, we have tax incentives. We can import the CBU cars fully, but in after 2025, we are not sure whether this incentive will continue, but the CKD incentive will continue until 2027. So Tesla will have another 2 years runway. And then coincidentally, if the Gen 2 platform is launched in 2025, then Malaysia will be definitely one of the first to get it. So you don't need to wait, you can get the CKD process done and then you get the incentive as well.
So I just want to recap this. Now, what we've heard in Investor Day, what we've heard from Dave Lee, like this unbox process is a great way to improve manufacturing efficiency, more parallel work. Tesla bots can eventually replace more and more humans in the production process. But what the big nugget we're getting from Kelvin right now is be after the factory, beyond the factory. This also helps Tesla to scale, to import to more countries. It reduces wastage from assembling the car, disassembling it again, reassembling it in a local country. This is pretty insane. So lower cost, lower wastage, more scalability, even outside of the gigafactory. Am I
Yes.
missing anything
So
here, Kelvin?
yes, so this will help Tesla to actually expand to like smaller markets where like more unfriendly, let's say unfriendly to the import cars. Like Malaysia, like probably Singapore. You see, like Hyundai is building a factory there, right? Why?
Yeah.
Because you get incentives if you build it there. So it's exactly the same. So that will really help their expansion. So you don't need to build gigafactories in every region to get the efficiency, but you build everything, you build the sub assembly at the gigafactory, and then you send it to different regions, and then let them build it, or make it so easy that a local assembler, someone with a screwdriver, can actually just fix everything together. Of course, I'm
I want to pause
exaggerating, lah,
you
right?
here
So
because what you just brought up is a big point. Last year, Tesla tried really hard to get into India, but it didn't work out. And a big part of it is the government wouldn't give like reductions in import tariff and required local assembly. But now with this new process, it is possible to enter markets like India, do local assembly in a way that doesn't increase cost or too much
yeah.
complexity.
Yes.
And
So
like
you
what you
do not
mentioned,
need to build a big gigafactory. So you sort of use the loopholes of the tax. I mean, let's not make it sound like a negative connotation, right? But actually you try to work around and then add some value locally. And it's easier to add value locally rather than building it somewhere, dismantling it, and sending it just to get that value. So this
yeah,
actually increases the efficiency lah. You reduce wastage lah. You don't waste all this time and money.
there is also precedent for this. So a lot of people may not know this. So we all know that Tesla's first factory is Fremont factory, but Tesla had for many years an assembly factory in Netherlands that
Yes,
does
exactly.
assembly.
This is the same thing. Yeah,
Exactly the same thing. So now
exactly the
you can
same.
go into India, you can go into smaller places, let's say like Sri Lanka, like Brunei, where it may have otherwise been impossible for Tesla to sell cars.
Yeah. And Rooster
Nice.
said correctly, COE not included. So
COE not
whatever
included.
Singapore still will be very expensive, no matter where you build the car. Yeah.
Thank you, Kelvin. Very,
Yeah.
very clear.
So let me check if I have anything I miss on this slide. So yeah, it allows the modular manufacturing efficiency, better top down. Yeah. So and this also helps the why I said just now, the ergonomics of the worker. And
Can I
yeah, I
ask Kelvin?
think one very I would say a lot of us, if you are now in engineering, you are one of a, maybe not a very new buzzword, but we tend to say DFM, design for manufacturing, which was what the also in the Tesla Investor Day, the France talked about design for manufacturing. So they found out that you should design for manufacturing, which is totally correct. But now I would say, right, they actually you can design at the manufacturing. So it's DAM now, I would say. So you can actually, do changes on the fly, which is way better because you don't need to stop the line, you don't need to, change. You don't need to like uh, have a show breaker, which makes everything stop. So you can actually design during your manufacturing. So it's quite impressive what they will be moving towards.
There was a question on margins earlier, Kelvin. So when they move to this new unbox process, this modular process, would we expect a decline in quarterly margins for maybe 1 or 2 quarters before it picks up again?
I would say for every RAM or new product, it's definitely going to be uh, affecting some margins. Definitely, it's just built in the economics. You cannot run away from it because everything new processes, right? You're going to try, you're going to test, you're going to have engineering man hours on it. So it's definitely going to cost more at the beginning. But in the long run, it will of course be it will balance out. I know it will slowly be very stable. When once it gets stable, you can start to improve the yields and everything. Then everything will definitely be more cost effective. But and also this process, I would bet the bottom dollar is going to be cheaper because of the factory floor space that you're going to use, and then the time is a lot of a big factor of manufacturing. So definitely going to reduce cost.
Can I ask Kelvin? So in Tesla Investor Day, they showed that because of these new processes, the factory footprint would be like half. But to a layman, like why would it require less factory space? Because it looks like there's more Lego pieces with more workstations. Can you help us
Yeah.
understand better?
So one problem with factory space is that currently the car is actually moving on a like a conveyor belt, or on a they have this kind of guided vehicles, right, to transport this kind of uh, parts. So the transportation is actually there's actually quite a bit of overlap because some parts are transported more than once. So for example, like the doors, okay, you are going to, from the stamping, you're transporting it to the first the body shop, and then you're going to put it to the paint, and then after you come out, right, you're going to disassemble again, and there's another route for you to send it to somewhere else to store, and then you do your assembly, and then the assembly is a straight line, right? So you cannot do parallel processes. So the straight line is going to be long, so that's going to be footprint. And so, of course, you're going to see more cars on the line, right? The output will probably be the same. I think last or someone said that it'll be like 45 seconds per car. The new factory on this process will likely be the same, but you will have less cars being like on the line. So you can see that it comes together. It spends less time on the line. Okay, that's what probably you can understand. So it's like, let's say someone who can make you have let's say you have a kitchen, right? You're going to make a meal, you're going to make like a 9-course meal, and the kitchen has a lot of employees, and then you're going to do it in series. You're going to make the first meal, and then every person will make one meal, right? And then you come out 9 course, 9 course, 9 course. But what if there are 9 people who are going to make each course at the same time, and then you're going to spend the same time to make it, but your line will be a bit shorter. You need to have people standing 9 people in series, something like that.
Very clear. What else are your key takeaways from Investor Day?
Okay, so moving from this, right, I was talking about the connectors, right? How are they going to test those kind of connections, and how are they going to reduce that kind of error or rate or problems when during assembly? So another thing that they use is that this software-based approach. They actually revealed this first time. Previously, I was actually speculating, like, there is a factory mode in the infotainment system. There's a factory mode, there's diagnostics mode, right? Why don't they use it to, when they are assembly, to check? But actually, they are using it. So my speculation was correct. So what do people on the normal assembly line do? See, the left picture shows the Toyota assembly line. So you see that small piece of paper? That's actually a checklist. So every station, right, once they did something, they will have to go to this checklist. They have to tick, and if there's a problem, they have to write down. Now, if you sense an error, right, or a problem with a part, let's say it doesn't fit, or I fit wrongly, or there's not enough time, the screw broke off, I will not stop the line if it does not affect the next part. I will not stop the line. I will let it move. But I will say this is defective. Rectify during the final check. Okay. And that's what a lot of car companies do. The line has to keep moving. If you have been to a factory, right, the line doesn't stop, it's actually moving. The employees are moving together with the line, right? So they have a certain time gap to finish their job. So at the end, right, there will be a final check and we will see, oh, this screw is not tightened. Okay, we have to tighten it first. Oh, this part is missing. Okay, then we have to disassemble and put this part inside. Things like that. Or maybe the radar wasn't working, or the radar, the operator dropped the radar on the floor, and then I cannot assemble it. It happens, it happens. So at the end of the line, they need to go through the checks again. So what Tesla is doing different is that they use the software because they have their controllers all together, right? They know the interfaces. It actually runs the checks and diagnostics while they plug the things inside, while they fit the I don't know, brakes or airbags or whatever inside during the assembly. So the diagnostics are run at that time. So if there's a problem, right, they will flag it, and straight away either you can run a software update because maybe the part was with the old firmware, they run a software update. Or if it's not plugged properly, then there's a signal saying, okay, this is not plugged properly, please quick plug together, plug on it. Or if you cannot plug, right, at the end, you have to, the next person has to plug it or something like that, right? They will do something. So all this is also very, very important because it gives data. So data is very important in processes. If you imagine you use a piece of paper, right? When do you get the data? You get the data at the end of the day, where the shift supervisor will collect and say, what went wrong today? Oh, this screw, very hard to screw in. Next day, can you highlight it to the engineering team? How do we change this way to screw, right? But if you have a software, right, there can actually literally be a person sitting somewhere with a dashboard, or the whole company, right, can actually get real-time feedback. So let's say I'm in charge of a screw, right? So I get feedback from the ground. This screw like always got problem. So right away I will solve it. Okay, so let's change this screw. And then my next day or maybe the next shift, I will say, okay, this screw change or change this process. No need to screw so tight, things like that. So it's very fast. So it helps as well, right? So it's not trivial. No, this is actually not trivial at all. The way that you have data help you, right, is really, really important.
So I just want to pause you here. So, like all of you in the live stream, like you see Kelvin referencing Toyota. Recently, Toyota executives, they actually dismantled the Model Y to try to reverse engineering. And Toyota's leadership said that the Model Y was like next level. Toyota, which has
Work
been a
of art.
manufacturing leader for decades, this work of art, they said we need to completely rethink how we build a car because Tesla has showed us what we probably previously thought was impossible. But now what Kelvin's revealing to us is not only is the build of the car itself so amazing, but the car software is actually integrated with the factory. So the car's computer is now telling the factory workers what's going on, what's missing, what's working, check, check, check. So the car and the factory are talking to each other. I'm not sure how many other car companies are doing this, where the car is telling the factory and the workers what you need or need not to do. And one day when the Tesla board, it's almost like internet, right? It's like Wi-Fi. All the boards realize, okay, there's a higher defect rate in this component. Let's fix. That's insane. This is like the Borg.
Yeah. And do you realize
Am I
that
overhyping this, or is this real?
no, it's actually very true. I mean, you see, even do you realize that Tesla cars have to calibrate when you buy the new car, right? You have to calibrate on the road, right? The
For
cameras.
autopilot.
Yes.
Yeah.
The why can they do this? Because they have the understanding of the cameras itself. They have understanding. They control their controllers. They control the interface. But for legacy automakers, right, who is controlling the interface is the suppliers. So the suppliers will provide tools to the automakers, so they have to calibrate at the factory. So there's an extra step. You have to have special signboards, or there's some special panels at the end of the line, and you need to calibrate at that time. Then only you can qualify that thing. Tesla also does that at the end of the line, but they go a step forward because in the real life you need to recalibrate because you have to calibrate to real life situations, right? Like the lighting and sometimes the position. Like your camera, you install a bit, saying it, a bit out of dimension, right? You still, because after shipping, right, there may be some problems as well. So you always calibrate at the end user, which is also not doable with the normal process, because they don't have that understanding or that control on that part. So they, and then this is actually a bit more deep lah. If some of you know, um the normal automakers, or most of the cars are using CAN bus. So it's a kind of a communication network in the car. And now, because with ADAS, with more data, they are slowly moving to Ethernet, which allows more communication.
Hmm.
So Tesla is already started, or already very into this Ethernet thing already. And I think the next step, right, they will likely go wireless, because you see the modular assembly, right?
Yeah.
If you're going to connect the different modules together, why don't you do it Bluetooth, or you do some wireless protocol, instead of adding another step for the assembler to click the connector together, which is another part, right? So I would say maybe they will move a step forward. No more, not even use Ethernet anymore. They will use like total wireless protocol inside the car. And then you save on wire harness. The last set also, they save so much by
Hmm.
increasing the voltage of the car. And after increasing the voltage, you're going to reduce your copper usage. You're going to reduce your current, right? So you're going to save a lot. What if you reduce further, you go wireless? So you have your brakes able to communicate wirelessly to your uh, let's say your ECU or your camera, something like that. So why not? Of course, there's some safety things that have to be considered, but it's not out of the realm of impossibility.
As I hear you say all this, Kelvin, as you put all these pieces together, I'm just thinking, if I'm an engineer from at Toyota or Ford or GM right now, I'm sending my CV to Tesla because engineers want to work on amazing things, and all this just sounds pretty cutting edge.
Yeah, I would qualify that with uh, adventurous engineers. There are engineers who are very cushy in their jobs, right? They will just do whatever is needed. But yeah, if you are a true engineer, right, you want to do something valuable, right, you will definitely go to these kind of companies, right, because you have more freedom. There are a lot of restrictions. If you were to be an engineer before, or let's say not an engineer, even a software developer, right, there are so many restrictions sometimes, right, we have to work around. But if you listen to how Tesla can attract talent and things like that, I'm sure it is because of the environment that they allow the freedom, uh, the adventurous person in you to try to challenge yourself, try to find solutions that are so unconventional that nobody will say no, you can't do it, right? People will say, okay, you try first, try first. And
Yeah,
that's very motivating, right? You try first. If cannot, okay, then never mind, we fail, we learn. Instead of saying, oh no, we don't do this, it's not something we do, so
that's right.
that's yeah, that's very important. The
As
culture,
Lucy has shared,
very cliche about culture.
this is a big recruitment event because it's so high on not just on vision but how the vision is being fleshed out, and I think that's really inspiring for engineers.
Yeah, I think I agree. I mean, what Tesla has always done with this kind of days is actually not really to placate those institutional investors, or those other people, but for people like me, right? You have been inside other companies, and then you can feel sometimes a frustration, but you see that it's it's like so eye-opening. You see a company like Tesla, and you feel that why didn't I work there before? Why wasn't this around when I was working, things like that. So it
That's
was
right. Even in
it's
the
very
live stream audience, you've just inspired Rosemary. When she grows up, she also wants to be a Tesla engineer.
yeah,
I think you
if
better
you do
get a
it.
referral code now for. They have referral code now for cars, for merchandise. I think we need a referral code for employees as well, careers.
Yeah.
What else are your big takeaways from Tesla Investor Day?
All right. So next slide. So another one is working on that previous slide, right? The software. How did they allow the software to control so many parts of the car? The software spans the entire system. Why? How? Because they own those controllers. They own themselves and they design themselves. They specify themselves what can the controller do. Okay. So they do have suppliers. Don't get me wrong. Some people say, oh, Tesla still get cameras from Continental, radar from Bosch. Of course, but they don't get the whole solution. I would say, right? They get the hardware. That's all, and then they understand how to interface with that, and they control it themselves. Okay, so they have their own ECUs and control units that interface with that camera or
Kelvin,
that
can I hold you here? I also watched the
radar.
Tesla live stream and I was lost here as well. Like, how is this significant to a lay person? Like, what does this mean that the controller is designed in-house, or if I buy from a third party, what's
Okay,
happening?
so in the normal process, right? Let's say you are building a car, so you want to have an ADAS system, right? You want to have lane keeping, you want to have emergency auto braking. So what a normal automaker will like, let's put Mercedes first. Mercedes is always on the forefront. They will go to a ADAS solution provider, right? They will say, okay, what do you have that can solve these certain cases? So what the provider will do, let's say Continental, right? I'm not disparaging them or anything. I'm just giving an example here, okay? So let's say Continental. They will say, okay, we have this, and this. Okay, we can look 30 meters, we can work in the rain, we have this product, we can control your brakes, we can lane keeping, we can give you all this. Okay, this is a solution. So what the Mercedes will then do is that, okay, let's discuss, is this usable to our test case? If not, okay, let's discuss again, let's tweak it. Then Mercedes may say, 30 meters is not enough. Do you have something for 50 meters? And then Colin will say, okay, hold on, let us discuss again, and then let's see if we can do something for you. And then discuss, and then they will come back to the Mercedes, say, okay, it's going to cost you, like, I don't know, $5 more. And then Mercedes will say, okay, hold on, let me discuss again with the purchasing. So you see the problem with that? There's too many interfaces. There's a discussions going on and no work is being done, No work is being done here, No work yet, It's all just discussions. Can I put this? Oh, let me discuss with my manager. Can I do this? Okay, let me discuss with my purchasing. Let me discuss with this and that, right? So these kind of interfaces all do not add much value, right? So what does Tesla do? They will go to the supplier, they say, okay, do you have something that can work in these requirements? Okay, then let's say Bosch, they say, yes, we have. And then the Tesla say, okay, how much? Oh, it costs this much for this hardware, but no solution. I'm not going to give you software. I'm not going to give you, control, anything. No controllers, nothing. I'll just give you the spec sheet, like a manual, right? Talk to it yourself. Okay. So Tesla said, fine. That's what we want, right? So they just buy. They say, okay, it makes sense. This price is enough for us, right? We buy. How much you can provide, right? They buy. And then what Tesla will do, I speculate here, is that they will design the controller so that it works together with their whole system. So they understand the product, they understand that sensor more on the hardware level than the other automakers, where the other automakers will know only on the interface level. They only know that your camera will send this certain signal to my certain part of the car, and I will only know that. But I don't know how you are going to process the signal. I don't care how will it switch off. I just want to know the signals that you give me. That's all. And that has been done all throughout the history, from brakes to airbags to the ADAS systems. And Tesla has very likely turned that around, where they make sure that all the systems are, they know what to do themselves. They only get the parts off the shelf, and those parts are just parts and not the interface, not the way to control them. They control it themselves.
Mm.
And that's why Tesla can update. That's why Tesla can update the firmware, because they have the hardware access. Whereas
Mm.
the legacy automakers, right, they only work in the interface. And of course, for security wise, you as a supplier, you are not going to give them access through the interface. The interface is just signals, right? So you cannot update one.
So it's almost like, I think of it, let's say like like two hotels. In the other car manufacturer's hotel, they only have the room card for a few rooms. Whereas for Tesla's hotel, they got a room card for every room because everything's integrated. Tesla really has the master
Uh,
key where everything works together.
I would say yes, almost like that. So go back to your same analogy, right? So there are two hotels. So what the legacy automaker has is they only have the room key for the front lobby.
Mm.
Okay, so the legacy automaker will go to the front lobby, said, I want to talk to the person in room 301.
Mm.
And the front lobby will say, okay, let me fetch that person. And then the person will
Oh,
come
okay.
down and then
They
talk to
do.
you,
Mm.
right? But Tesla will have what you say, they have the access to all the room keys. So the
Mm.
Tesla do not need to go to the front lobby. They want to speak to the person in room 301, they go straight to room 301. Does it make sense?
This is the way.
Yeah. And that has been the strategy of a lot of automakers, because they have been outsourcing a lot of things. It makes sense because they can outsource. They are not going to pay software engineers to work on that sensor, because they say, I want to buy and let you do it. You as a supplier, I pay you, you give me a price, and that's all. I'm not going to spend resources. I'm not going to hire a camera engineer to program that camera. The camera engineer will just make sure it works with my car. And that has been all the while. And
Can I ask how
has
big?
changed.
If
Tesla is actually understand the camera.
and if this is so good, do you see enlightened companies like BYD? Are they recognizing the same? Are they doing more vertical integration like Tesla? Or is their
Probably,
vertical integration different?
probably,
Mm.
probably. Yeah.
Mm.
It has been very lucrative for those part suppliers, like Bosch and Continental. It has been very lucrative because they give a black box solution,
Mm.
right? They create that solution, like let's say lane keeping, right? And then it makes money, because let's say the
Mm.
hardware costs like $30, but if you sell a solution, it can be like $100. So the margins for software is very high one. But what does Tesla do? They just buy the camera. The camera, okay, you just sell me hardware at $30. Don't sell me software. I'm not going to use your software. You sell me the camera, give me the access. I take all the liability. You sell me that camera, that's all.
Very clear.
So that's where the
What?
margins are as well.
That's true.
Mm.
As you remove more middlemen, more people who are doing things that you can do yourself, okay, it just means more profits. It's like removing dealers, distributors from the sales channel.
Yes,
What
and because of this, right? Because of this interface and very close work, it's always easier to work with people in your company than someone in another company. That's why I said just now, discuss, right? It's going to take a lot of time, because let's say you are the camera engineer in Mercedes, right? You need to change something for your car. You have to go to the supplier and say, hey, can you please change? I'm going to schedule a meeting, and then the meeting will be like next week, and then suddenly someone's fall sick, someone's not going to do it. Things like that will happen. Sure happen. And then it's going to be back and forth a few times. But let's say Tesla knows what is happening, right? They're gonna just say, hey, uh, let's say, I don't know, Michael, this camera is not working. Do you have anything solution? Then they're gonna do it there and then, right? It's not, you're not gonna have like bureaucratic processes, billing this, billing that. You're just gonna do it because it's for the company, right? You're
That's
not
right.
gonna, yeah, it's all for the good of the product. It's really more effective.
What
Because
else is another
I
quick
myself
tip?
has gone through has gone through these kind of processes. So a lot of my time are wasted in meetings. I'm sure everyone has also gone through this. So meetings, but no work is done because you are not sure if your work going to be wasted, right? Because if you, let's say you do and then the customer doesn't want it, it's going to waste, right? So then you don't do it, you wait first, wait for the green light, right? And that is what is happening in a lot of companies.
True. What else
Right.
excites you?
All right, then let's move to the next part. We go to the powertrain. So I say powertrain dominance, right? And it's not exaggerating. So why do I see Tesla as being a more dominant in the powertrain? So in a car, in the old car ice vehicles, right? The engine, you own the engine. You have that edge, right? You must always be faster, more efficient. Nice sound and everything. So BMW has been, the engine maker. Uh, Daimler, Mercedes, all has been engine makers. Now it has turned around, right? Powertrain for electric motors. Now, electric motors is not rocket science. Not
Mhm.
rocket science. It's a very simple machine. It has been around for at least 1 century, right? But why is it dominant? It's getting that package correct. Packaging means it must be compact enough, it must be efficient enough, and also to automate the process. Previous engines, the ICE vehicles, right? Internal combustion engine has a lot of manual processes. If you go through an engine manufacturing line, right, there no robots one, everything human one, all built by hand. Okay, you have to put the things together. It must be very gentle, things like that. There's a streamlined process, of course. And if you see the current engines, right, it's getting more complicated as time goes by because of efficiency and emissions. You need to add a lot of things. Now, for electric motors, it's the other way around. You're actually trying to simplify it further so that it becomes more efficient. The more things you add in an electric motor is actually more non-efficient. So
Mhm.
you have to have tools for that. So Tesla has the tools, but I'm not discounting the fact that other companies have the tools as well. And what Tesla has done is that they also focus their energy a lot on this. Like, for example, the Model S flat motor, right? We have heard the rotor. The rotor is the part inside that turns. This is the stator. Stator means it doesn't move. This is the
Mhm.
part that outside, right, doesn't move. The inside the stator, that one they say they use the what carbon fiber wrapping or whatever. Okay? So this kind of new innovations are always being done now, right? So now the problem with the Model S flat motor was that you see the part on top, right? The one that I put the arrow, that
Yeah.
was copper windings. So copper windings means that it's very thin wires, and then they use a robot to wind it up. Now, the problem with copper windings is that, or the problem with robots or automation is that the more flimsy the part is, the more difficult to get it right.
Mhm.
Right? So, like if let's say I ask you to grab a piece of thread and to form it, to make it into a certain shape, is it easier than I give you a thick wire? So a thick wire will be easier to shape into the shape you want. And so that is the next evolution of what Tesla is done. So this is only like half a millisecond in the video. I actually captured it from the video. Okay, you see this part?
Amazing.
This is actually a
Yeah.
part that they are actually building the powertrain. So if you zoom in, right, you will see the copper pins on top. You see the brown color one,
Yes.
right? So it's no more windings. It's this kind of, they call it the hairpins. Okay, so can you
Like hair.
imagine robots have an easier time to manipulate these than thin wires,
Mm.
all right. So, and that's what they are moving towards. So this is not new as well. This is not new. This has been done in the Volkswagen ID3, actually ID3 or ID4. Okay, So it's not new. But what I want to say is that Tesla moved towards this because probably because this one actually has a problem with heat because of the thicker wires. So probably Tesla goes to this because they want to mass produce this powertrain.
Mm-hmm.
So it makes no sense to go to. It probably will not be as fast as what we have now, but it's sufficient, I would say. Sufficient, right? For a mass-produced vehicle, for mass market. So you're not going to drive, you're not going to sell a $25,000 car that goes 200 kilometers per hour. It doesn't make sense. It's wastage, right?
Okay.
So they probably go to this and then they want to, expand it further. So what does this bring? This brings this one. It makes it more scalable. And that was what the Volkswagen has been doing. You
Mm-hmm.
see, other car companies did not go through this because they did not expect electric motors to be so high volume. So they go to the copper windings, which is cheaper, okay, and it's more, let's say, forgiving, okay, during manufacturing. But now they go to hairpins. So why? So they go to hairpins because they know that you don't need to have very fast cars, but you need to build a lot of motors. And so
That's
the
right.
next powertrain will be around $1,000, which is mind blowing.
How
Okay,
much cheaper is that compared to the current powertrains? Can you give us some benchmarks,
fifty
please?
percent,
50% cheaper
yeah, roughly.
than Tesla or Tesla's competition? Because Tesla is already more efficient.
No, Tesla's motors are not cheap.
Okay.
It's actually not cheap because of the way they manufacture is not cheap. The laminates they use, then the magnets they use is not cheap. So I would say that would be a right amount, also about $2,000, 2005. Depends on which motor as well. They have two kinds of motors. They have
Okay.
the permanent magnet and there's the synchronous or something like that. Induction motor, sorry, there's also another one. So they have two. So it depends on the usage. I can't remember which is which really, but there's a difference as well. Some advantages and some disadvantages.
So this one
But
here,
this one here will
half
be the cheaper one.
half the
I would
price, slightly slower top speed, but otherwise a lot more scalable.
Yeah, I would say around half I would say around half because from experience, the Plaid motor, the Model Y motor, performance motor is not doesn't seem cheap because you see the way they build it up, it's not cheap. So for this one, if they go through this route and if they have the numbers right, it will be feasible to go 1,000. And then they say 75% reduction in the footprint. It works with all kinds of battery chemistry, and this is very important because you want to be modular. And that's why I said the new Gen 3 platform is not only for one vehicle. It's going to be at least 4 or 5 vehicles, different shapes, different formats. Otherwise, it's not going to make sense. And that is what they are moving towards. Then only it makes sense to, you know, use automation to bring all these processes together and try to pump out like 10 million cars and so on every year. So this is the what they are going to move towards, and also $1,000 is actually way cheaper than an ICE engine. An ICE vehicle nowadays, right? Even a small vehicle will be $3,000 the engine.
Mm.
But if an electric motor is 1,000, and of course you need to add the batteries in the because in the ICE vehicles you don't count the fuel tank. My fuel tank is just a big, just a plastic or a kind or like a Kevlar coated container, right?
Yeah.
But you as a normal combustion engine, right, it's around the range of $3,000. So if you
Okay.
if you have a car now, you wreck the car and you need to rebuild the engine, you buy a new engine, it's about $3,000. Okay, for a
I want
normal
to give,
Toyota engine.
I want to give the audience a sense of scale of these savings. And you have questions, continue sharing them in the live stream chat. Now, Tesla aims to make 20 million vehicles by 2030. So if they're saving $1,000 minimum per powertrain, that is $20 billion of savings per year. 20
Yeah,
billion in
yeah. That's why
savings.
don't underestimate this kind of savings. Even saving $1, right, or one penny, right, is a lot of money. we had a saying before in Nokia, when we save 10 cents, right, in the part, right, our whole production now, we can buy 3 Porsches already. You know?
It's insane.
Yeah. You can save like 300,000, 400,000 euros just by saving 10 cents. So it's don't underestimate this kind of saving. So you can save $1,000, right? You can save like billions. You can build a few more factories. Really, it's really insane. Right? That's why you can sell the car, and then you know the demand curve, right? If you reduce by 1,000, you get more demand. You use by another 5,000, you get more demand, right? It's all play towards creating this kind of demand, man. So and then you
Solid
imagine, right? You
calculation.
imagine a car engine is now like $3,000 a year. An engine, a normal one, no turbo, whatever,
Yes.
just on average, right? Now we add batteries, right? It's going to be way more than this. If you add batteries, right, current
Exactly.
prices, right, 50 kilowatt hour battery will be like what? 3,500 or 4,000. Let's say 4,000, very conservative. $4,000 for a battery pack, plus this is $5,000. But you can imagine, right? $5,000 for the powertrain, right? Don't you think a $25,000 car is actually feasible already?
Very.
Yeah. Five
So
thousand dollars. Let's say you sell the car, your cost is 20,000, right? Why not? 15,000 for paint, for brakes, for whatever thing you're gonna put around the car. But your most important part, your powertrain is like 5,000 or 6,000, let's say, bigger battery. It's already sort of compatible, comparable to a ICE, sort of. Why you? But then you may ask, but engine is 3,000 or powertrain is 6,000. How can it be comparable? But think about it, a car has a transmission. Transmission costs money, the gear costs money. And then what else? You have the cooling system for the gears. It's also cost money, one. Cooling system, oil, all this fuel pump, all this is money. Probably it'll be comparable or slightly more expensive, a bit compared to engine. But that is current prices. What about 5 years later when battery prices maybe go down further, right? Then you'll be very
interesting.
competitive already.
Simon in chat saying like, why bother investing in other companies? So a slight off tangent here. So like the power, people think that when Tesla cuts prices means automatically margins worse already. But now we're hearing from you with all these changes that are happening, it sounds like it's still possible for Tesla to bring down costs faster than any price reduction. And I think if we've seen, we remember the last quarterly earnings, Tesla was showing over a 10-year period, their average selling price went down from 100,000 to 50,000, but their gross margins operating profit went up by double or triple. And this is evidence that Tesla can continue doing this at least for the next 5 to 10 years, just by third generation platform.
Yeah.
Am I missing something here?
No, you are perfectly right. I mean, you cannot just. A lot of us maybe tend to think that linearly, or maybe to tend to think, like if you reduce this, your profit margin is definitely going to be affected. Of course, yes, it will be affected, but it's not affecting. It's not going to be affected linearly, right? Because you may reduce, like, let's say $10,000 from the Model Y. Okay, you reduce $10,000 from the Model Y, you're going to get a peak in demand, and then because of the volume increase, right, you're gonna get more out of your current capital expenditures. You're gonna get more out of your factories. You're gonna get more out of your processes.
That's
So
right.
probably you go down 10,000, right? You are not going to lose 10,000. No, you're probably going to lose like maybe 4,000 or 5,000.
On
So
top of that, when you sell more cars, it means your competitors sell less cars, which means that the
mhm,
capex efficiency goes down, which means your competitors' costs go up. That's insane.
yeah, and also Tesla has other business lines, right? Like for example, their supercharger. If you're going to sell more cars, you're going to make more money from superchargers, right? You're going to
Yes,
make more money from their software, and then you're going to, of course, it's not significant these days. I mean, let's be honest, right? It's not significant. But if you're going to sell more cars, then you reduce the cost on the car, right? But then let's say someone will suddenly say, okay, I want to subscribe to the FSD. That's recurring revenue, right?
that's right.
So it's always a play of numbers, but let's not forget that every number affects the other number. It's not just you reduce this, definitely this will only reduce the same amount or something. So we need to sometimes look at the big picture, see how the interplay. So that's why also why I want to share. You can see that don't look at the surface. Sometimes don't just look at what everyone shouting about margins are going to be zero. It's not totally true, right? It's not totally true because things are always moving. You have to remember that even not only Tesla, like Volkswagen, BMW, everything is moving. Every day there are thousands, or not, if not hundreds of thousands of engineers, workers, employees are all trying to reduce costs, increase margins, working. So the improvement will always come. Who's going to be faster? And that's the one of the biggest question as an investor. Who are you going to bet your money on? So, and you have to deep dive a bit, like what we are doing now. Try to deep dive and see, is it feasible? Is it, and then you have to maybe put a bit of faith, right? Because whatever the management say now, right, it can be totally bullshit, isn't it? But
Right.
put a bit of faith, and then maybe a bit of like I would say a bit of logical thinking, critical thinking, like seeing that, okay, if they are going to do this, how feasible is it going to be, in the future? And maybe look back at their track record. How has they been doing it? How has other people been doing it, right? So I would say I would give this a very high chance of succeeding, actually more so than the one piece casting. One piece casting, I would say, is really, let's say, a bit of a fiction, in my opinion. A bit of fiction. It's I would say it's physically not really possible at current technology, or it's going to be so expensive that you're going to have to at least sell like maybe 1 billion cars to make sense or something like that. It just doesn't make sense, because you can't cast parts where inside is hollow. You cannot. It's every die cast part you see that it's not hollow one, but how can you cast parts that are hollow? It just doesn't make sense. So you cannot one. So that one,
For those of us
but
who are
front and rear
engineers, how do you
casting
see that?
is definitely feasible. Yeah, and Bunti said 3D printing. Yes, if 3D printing is cheap, you can do that. But 3D printing is slow, and that's also a problem. 3D printing is very slow. You're not going to get cars at 45 seconds. You're going to get cars at one car every day or something like that. So it's not possible. And then the next part of the slide is just the rare earths part, which I think is also amazing, because a lot of magnets uses rare earth, and then environmental issues, things like that. So if they can eradicate the use of rare earths, that's really kudos to them. You're going to save a lot of money. Rare earths are so expensive and also so rare, or rather so polluting, right? So always good to reduce the use of rare earths.
How did they achieve this? How do they not use rare earths?
I would say they use simulations. I would say they use simulations, and then they play around with geometry. They play around with metal compositions.
That's very
Yeah,
impressive.
I'm not
Well,
an expert in. I'm not an expert in this kind of electromagnetic processes, but from what I see, I would say simulations can help. Simulations and maybe probably some optimization processes that they have refined.
thank you, Kelvin. Now
And
let's
that's all from me.
now we'll do a short recap with some audience questions. We'll wrap it up together. Ivan's asking, why aren't other companies ordering giga presses? I believe some companies are. I think BYD is ordering giga presses
Volvo,
as well. Kelvin, any other
Volvo,
insights you can add? Volvo is also
Volvo is
using giga
ordering. Yes.
presses. So I think the whole casting giga presses will become a bigger part of the industry.
Now, why legacy automaker don't use before? Because they their cars do not sell at the volume that Tesla sells. That is the only reason why they don't use casting. Because casting has to have a certain volume to make sense. You don't see Model S and X using casting because
Correct.
they only sell 20, 30,000 per year. It's not feasible, not worth the effort, not worth the time, not worth the investment. You need to have a car that sells like 50,000, 100,000 at least to go to casting.
So, like example, Toyota Corolla could probably do casting.
Yes,
Volkswagen Golf
yes,
could probably do casting. But the
yes.
challenge here also is in the industry, most car companies still think I need to have 20, 30 models. They're not.
Exactly. But the front and rear will stay the same, of course.
Mm,
But because what you said, you're going to have like 20, 30 models, right? So it eats up into their the mass market model. So then they will feel that let's not do it. Who knows, if it doesn't sell well, right?
that's
Then
right.
let's not do it.
So Elon was, I think, asked that as well. And he said roughly Tesla would have roughly around 10 models all in, even if you include the van, the robo taxi cars, all in 10 models. That's it, which is still
Mm.
half or one third of the current fleet of most other car manufacturers. Kelvin Bunti asked earlier, what was one thing you wish to see in Tesla Investor Day that was not shown?
New car model. New
Yes,
car
many
model.
of us
Yeah.
do. It seems like Elon and team were saying that there will be a separate product day, and it feels relatively
Mm.
soon.
I think maybe it's not finalized. They don't want to go to the mistake again, like launching something too early and then in the end, 2 years, 3 years, probably 2 weeks, it just doesn't make sense anymore. So they feel that because it's going to be a mass market model, I think what they want to do is that they're going to make sure that everything is done. Everything is, like probably already in like beta stage. And then they
Yeah,
will just say, okay, you can order this after the show, you're gonna get it in 1 month,
exactly.
things like that. Yeah,
So actually, if you
at
look at
least
the
for
history
US
of
lah.
Tesla events, usually after most Tesla events, the stock price goes down, like Tesla Investor Day. There's only one Tesla event so far that we know of where the stock price goes up. And that's the Model 3 reveal and launch event because you actually allow people to immediately order a Model 3 then. So institutional investors saw and it's like, whoa, that's crazy. People ordering Model 3 like nuts. Stock price went up immediately after Model 3 event. So to Kelvin's point, with this new mass market third generation car, if it's selling for $25,000, they probably want to announce it and then it's ready for order there and then.
Yeah,
That's
at
the
least for
event that I
US.
will that's the event that I will buy more stock before the event, not after the
Yeah,
event.
probably lah, probably, hopefully lah. But
Yes,
usually cars are not like consumer goods, right? So you cannot like global launch. It's likely not possible because there's just so much things to do, right? But
mm,
but actually, to be honest, right, even before Apple, right, a lot of global launch consumer products has not been done before. Actually,
mm,
Apple probably is one of the first few that actually says, we're going to launch in like 5 countries, and then next week will be like global launch. It's actually not easy, not easy to coordinate all these things. Yeah. So a car probably start in the US and Canada, and then maybe 3 months will be in the Europe and
that's
China,
right.
and then half a year in the other markets as well. That
So there are
so
questions
totally
in
different.
the chat. I am in a hotel room, so you can see this is like a hotel room. I am in Chiang Mai the next 2 nights. It is 1 hour earlier in Chiang Mai. It's actually 10:18 p.m. So I'm still enjoying one more hour of the night. And Sheldon was saying the stock price did go up after stock split announcement. So fair. I don't know whether was stock split an event or was it just a press release.
It was press release.
Hmm. So
But don't try to connect this kind of events too much to this kind of price movements. I mean,
agree.
actually, if you really believe and really understand the company, right, it's if it goes down, right, it's actually you actually get more information, and it's actually supposed to be a buying event, rather than a price go up event. If
Yeah.
I have money, I would likely buy more after seeing what they have announced yesterday
So it sounds like
or
your
this morning.
conviction went up. I've asked
Yeah,
also in
yeah,
the
definitely. I mean, you look into this kind of insights. I mean, you're not going to get this kind of insights from Mercedes and BMW. Did you see the Mercedes strategy update last
no, sorry.
month or something, last 2 weeks?
What's
It's like
different?
it's just a full marketing event. It's nothing. You have the board of directors there standing with their suits and then talking about how great they were and how
Mm.
great they're going to be, but nothing. It's all just fancy renderings. At least Tesla gives some numbers. So at least there's a KPI, right?
That is true. I asked also in a recent poll today whether after watching Tesla Investor Day, did your conviction for Tesla go up, stay the same, or go down? For most of you, your conviction have went up again, but it's about 48% of you. It's not like everyone conviction went up for everyone. So I think everyone's expectations was different. There's some fair criticism
Of
that some
course.
people felt that this wasn't really an investor day, or maybe it was a long-term investor day, but definitely not a trader day, not a short-term
Yeah.
investor day. And so the expectation setting for this event could have been done better.
Yeah. It's a I would say it is along the lines of Tesla lah. If you understand how Tesla present things, it's along the lines of Tesla.
Mm.
Is not. I mean, I would be more shocked if Tesla were to come out and say, okay, we're going to do stock buybacks tomorrow. We're going to sell. We're going to sell. Our revenue will grow 50% every year, and then we will make sure we give dividends 50% payout ratio. All this that would be the day I sell the stock.
Agree. The day that Gary Black is very happy could be a bit worried too. Kelvin, the live stream is asking you in the chat, what's your real background? Are you in the Matrix? Do you have a lot of monitors behind you? Are you in a car
No,
workshop? What's going on?
I'm in my bedroom. The
Oh, there
background
you
is
go.
fake. It's fake, right? You can see, of course, but hopefully my new house will become like this. But no, no
Yeah.
fireplace.
You're building a new house, right? So you also have your own giga home construction project coming up.
Mm. And cost overruns,
Cost overrun.
like
Okay,
every
this is not the
project.
Tesla way.
Yeah, not the Tesla way. No agile. No agile.
Right now. Okay, I see some
Waterfall.
new questions in the chat. Ivan's asking, can we talk about a mature FSD? So, Kelvin, can you share the audience what are you presenting there, please?
Oh no, no, this is not the agile way. This is the waterfall project management way. So I'm not
Thank you
using
for
agile to
sharing that.
build my house.
So
Yeah.
Ivan wants
What?
to know about
Sorry.
FSD. If FSD full self driving is mature, okay, so I think there's two parts of this question. So one is FSD. Is it a when or is it a if? And then second, once it really becomes the vision that Elon Musk has, what does it mean for you?
Okay, so I think firstly, I'm not the expert in AI or in machine learning, so I can't really imagine if it's totally feasible. But from what I see now, what they can do now, right? The capabilities are definitely there, right? So how feasible it will continue or will be, that will be a lot of there'll be a lot of contentions that I can't give a timeline or what. I would say we will reach there. It's just a matter of time lah. Again, I can't really say. But if like say right, if it happens right, I think it will be really a change in how we travel, how we treat mobility, how we treat vehicles. It will totally change a lot of. It will kill a lot of businesses, but it will give birth to a lot more businesses as well, right? So I mean, the one thing that we can really see now is that like my car, I pay so much, right? But I don't use it more than I think 5% of its life.
Hmm.
It's like a lawn ornament. It's a very expensive lawn ornament, right? So imagine if it can drive itself, and then I know I can fetch my niece, I can bring my parents, I can things like that. So it will be utilized more. So of course the value will be there. But I I can't say when it will be matured. There's a risk though. I think AI is like a black box. That's a problem nowadays. because regulators, right, they like to, when they regulate, they need to know how it works and why it works. But even software AI developers, they actually don't know how the AI works on actually. They don't know because it's all like weights and matrices, but they don't really know how it works. So it will be an issue, I would say, to get the regulators to be on board to understand what is AI. And I think we will get there when we see the real impact, how it will bring value to our
Hmm.
lives.
Let me add on here and then wrap it up. By the way, some of the audience members, they thought you were Kelvin L learns investing, but actually you're Kelvin
No,
learns engineering. So Kelvin L's, two
no,
different Kelvin.
Kelvin learned engineering
Kelvin
because
learns
I'm not learning
engineering.
anymore.
I just want to build on Ivan's point. FSD, Elon Musk has said this a few times and also this morning Tesla Investor Day, that it would be the biggest asset value increase in history. So you think of it this way, I'm an Apple investor, I got iPhone. I think a number of you have iPhone, right? You got iPhone and put in the chat. Let me know you got iPhone. Just give me an Apple logo or tell me you're an Apple fan. Now, if you got an iPhone, FSD is like, imagine if you remove the App Store from your phone. How much of your utilization of the phone will go down? You remove App Store. No WeChat, no Skype, no TikTok, no other apps. Same thing. FSD does the same thing for your car. FSD is like adding an App Store to your car. The utility goes up a lot more. So if the iPhone
Yeah,
is worth
more.
so much because of the App Store, FSD is going to do the same thing to your car.
Yeah, more people will actually be able to use the vehicle more, and then you're going to not need so much resources because actually you come to think of it, it's really a waste. The car actually lives at your parking space longer than actually you use it. Every car is the same. Every private vehicle is the same.
I agree. A lot of Apple users here in the chat as well. So Kelvin, thank you so much for sharing your view. What you've just done for us is you help us peel one layer of the onion to really truly appreciate what many others do not see. And this is really the heart of long-term investing, to see things that others do not see. But the moment it happens, then it suddenly becomes very obvious to everyone. It's like, of course, rockets are reusable. One day, of course, cars can drive themselves. One day, of course, robots are everywhere. Of course, so much. And that's, I think, the gift that you bring for us tonight, Kelvin. Thank you.
Thank you as well. I mean, that was very nice words, very kind words, and I hope to interact more to share. But I need to say that I've left the industry already 7 or 8 years, so maybe some of it might not be accurate enough, right? So I welcome any critics, any feedback, and if you think that anywhere that I'm not accurate or wrong, just send me something, message or whatever. I'm always I stand corrected, right? You can always uh, show me new things that maybe I've missed, and let's just keep the conversation going.
Thank you. I'll put a link down in the video description later where you can find Kelvin on Twitter. If you found this video useful, please click the like button. Share this and click subscribe to stay updated to more videos on Tesla. You're hearing this live for the first time. That's pretty cool.
Yay! So
Thank
everything
you,
went
everyone.
smoothly. So thank you
Yeah,
for
all right.
everyone. Thank you everyone who spend a evening with us. Thank you, Darren.
Welcome. For all of you, have a good night. Kelvin, stay back with me as I end the broadcast right now.
Bye bye.